Hi, and thanks for watching another instructional video for CSCI 1300. In this video, we will talk about how to insert an element into an array, whether the array is ordered or unordered. By ordered, we mean that we have some type of sort to our set of elements. So they're in increasing, decreasing order, or something like that. They have some relation to their ordering. With unordered, we mean it's jumbled and that there is really no rhyme or reason to how things were added to the array. A couple of things to point out before we get into how to insert into an array is we should look at the fact that we have some constant capacity set. And this is kind of like the upper floor or the threshold of a maximum size that either A or B could have. And we have some size A and size B variables which represent the current size of A and B under the capacity. So this could be, we could set the size to be less than the capacity, and if we need to, for some reason, we can increase the current size of the array until we actually get to the capacity that we have allocated. So let's see here. Let's go over an unordered array insertion. So in this example, the basic idea here is that we have some new element that we're going to insert. In this case, it has the value of 88. And what we want to do is we want to say that as long as the current size of the array is less than the max size that we can possibly have, what we're going to do is increase the current size by 1 index position. So if we have 6 index positions, we're now going to have 7 index positions. We're then going to go to the last index position available in A, which is the new index we just added, and insert the new element at that location. So we're basically just tacking on a new element to the array that we already had that was unordered. Let's look at this when we run the code, and I'm going to print the array before and after the insertion to explain what's going on. So we can see here that the element we are inserting is element 88. We have an array that has an order or a list of elements as 5, 7, 10, 13, 2, and 0. And you can see that after we insert, 88 is now fitted right after the 0. So we added one new index and then inserted 88 into that new index location. So now I want to shift and talk about how to insert into an ordered array. In this case, we're going to be dealing with an ascending order. So 1 through whatever, in 1, 2, 3, 4, 5 kind of order. So we have some new element 22 that we want to insert into array B, which is ordered. In order to do this, we will need to have an index that we will have to specify for where to insert the new element in this list of ordered elements. And similarly, we're going to have to check to see if the current size of the array is less than the max size or the capacity. And if that's the case, then what we can do is we can use a loop and a simple statement after the loop to execute this insertion. So to break down what's going on in the loop, what we're going to do is we're going to start at the end index of the array, so at the last index available. So this is size minus 1, the current size minus 1. And we're going to go in reverse order from the last index to one more than the insertion index. So if we wanted to insert at index 4, we would start at size minus 1 and continuously loop backwards until we were one more than the insertion index, which would be 5 if we were inserting at index 4. And when we do that, what we're going to do is we're going to take whatever element is at that index and swap it or shift it down to what is below it. So this would be on the first iteration, this would be the size minus 1 element being switched with what is 1 less than size minus 1, and so on and so forth. So wherever we're looking, we're basically saying whatever index you're at, change the value at that index to the one before it. After we get to that index, once we get to one more than the insert index, so we've shifted everything down at this point to be in an ordered way. We have basically sorted everything above the insertion index, and everything below the insertion index has already been sorted, and we haven't touched those. So what we're going to do is that after we get to that one more position, we know that we have shifted the open entry. So assuming that the last entry in the array was open, what we're doing is we're shifting the open entry to the I-1. So say we had 0 at the end of our array at size -1, what we would be doing is shifting 0 down until it finally reached the insertion index. So all of the other values we would not be changed. They would be in the same order, except we would have moved that 0 element to where we want to insert the new element. And once we do that, we'll overwrite that 0 element or that empty element with the new value. So let's take a look at that when we run the code here. So we're going to insert 22. Let's go ahead and use index 4, like we've been talking about, to kind of give an idea of what's going on here. So before the insertion occurs, we have 1 through 5 in an ascending order with an empty element of 0 at the end of the array. What happens here is that we start at size -1, which is where the 0 element is. We shift it with 5. So 5 takes the position of 0, 0 takes the position of 5. After we insert, since 0 is now where 5 was, it's at index 4. So that's why we have 5 at the final position of size -1, and 22 has now overwritten the value of 0 at index 4. That's all for inserting into arrays, whether they be in sorted or unsorted order. Thanks, and happy coding.